The first and second terms of a geometric progression are p and 2p respectively, where p is a positive constant. The sum of the first n terms is greater than 1000p. Show that 2 to the power of n is greater than 1001. This means that we need to write an expression in terms of n and then simplify it so that it becomes 2 to the power of n is greater than 1001. And if we look at the main piece of information, the sum of the first n terms is greater than 1000p. From the formula sheet, for a geometric series, we have a formula for the sum of the first n terms. Since the question says that the sum of the first n terms is greater than 1000p, this means that we can set this expression to be greater than 1000p and somehow try to rearrange it to make 2 to the power of n is bigger than 1001. But if you compare the two expressions, the expression that we want does not have a p, does not have an r, and does not have an a. This means that we need to somehow cancel out the p, the a, and the r so that it becomes 2 to the power of n is bigger than 1000p. And we can do this by trying to write a and r in terms of p and hope that it will eventually cancel out with the other p. From the other pieces of information, the first and the second terms of a geometric progression are p and 2p. The first term is equal to a, therefore a equals p, and since the second term is equal to 2p, we can kind of write out the geometric progression. In a geometric progression, the rule is to multiply by r each time. This means that p multiplied by r should equal 2p, and therefore we can solve for r, and we get r equals to 2. With r equals to 2 and a equals to p, we can substitute these values for r and a back into our original inequality. Now, our inequality are only in terms of n and p, so we need to try and cancel out the p. When multiplying by -1 to both sides, don't forget to switch the signs of the inequality. And finally, we rearranged to make it 1001 is less than 2 to the power of n, which is the same as 2 to the power of n is greater than 1001. In another case, p and 2p are the first and second terms respectively of an arithmetic progression. The nth term is 336, and the sum of the first n terms is 7224. Write two equations in n and p, and hence find the values of n and p. The question specifically tells us to write down two equations in n and p. This means we need to use the information that was given into the question to write equations. The first main piece of information is that the nth term is equal to 336. From the formula sheet, we have a formula for the term or the nth term of an arithmetic series. This means that this expression from the formula equals 336. The second main piece of information is that the sum of the first n terms is 7224, and from the formula sheet, we also have a formula for this. This means that we can set that expression from the formula to equal to 7224. So now we have two equations, but two equations in terms of n, a, and d. This means we still need to rewrite a and d in terms of p, so that everything is in terms of n and p. We can write a and d in terms of p by using the other piece of information given. P and 2p are the first and second terms respectively of an arithmetic progression. The first term is equal to p. This means that a is equal to p. And the rule for an arithmetic progression is to add d to each term as you go along. If the second term is 2p and the first term is p, this means that p plus d should equal 2p, and therefore we can use that to solve for d, and d equals p. Now that we have a equals p and d equals p, we can use this and substitute it back into our two equations we got. And now we can simplify and solve these two equations simultaneously to get our values of n and p.